Normally my videos are a look at what I made type videos, but instead I want to try something new.
Devlog.
And this is going to be my first one. Hopefully in this videos I'll try to be more myself, as you heard there. I'll try my best on making a video bi-weekly or monthly. I'm going to be making a game engine called Vyxen, with that spelling. With the one. It's not a typo. It's not a bug, it's a feature, alright? I decided the very first thing I wanted to add was a physics engine. That's actually how the whole idea started. I split the engine into 4 crates: math, geometry, physics, and Vyxen. I followed a tutorial by 2-bit coding. If you want to make your own, I'd recommend starting from there. Let's start on it now. One really important thing is that we have a good vector structure. X and Y is floats and multiple functions. Some of the more important ones are length, distance, normalize, dot, cross, and transform. Rigid bodies. It started out as only 2 different shapes, circle and box. Like here. Wait, what? Like here. Then I added some functions like moves by, so they can move. So let's add some collisions. Circle collisions are pretty simple. Compare the distance between the 2 centers to the combined radius. If they're overlapping, they're colliding. If we get the normal and the depth, circle B is moved by the collision's normal times half of the collision's depth. Circle A is moved by the same amount except the normal is flipped. Now we can push the bodies apart. Before we do polygon collisions, we need to make transforms. When a rigid body is rotated, we need to recalculate its vertices. Now let's do polygon collisions. It starts by looping through each edge on vertices A. It makes an axis parallel with the edge. It projects vertices A, then B on the axis. It's kind of like a shadow on the axis. If the shadows don't touch on any axis, they don't collide. It does the same thing, but instead loops through vertices on B. This technique is called separating axis theorem, or SAT. And it just works. Nearly. Lasting on collisions for a while. Polygon to circle collisions. We do the same thing, but instead we cast the shadow depending on the radius of the circle. Since that works, let's do some slightly lighter things. World struct. The world struct just holds all the bodies and manages collisions for you. Also, the world repeats everything multiple times in the step function to help reduce the amount of precision issues. Because yeah, that happened. I made the rigid body move with gravity and forces. Instead of objects instantly stopping, I added restitution. Think of it like comparing it between a bouncy ball and a tungsten cube. One bounces, one doesn't. I made static rigid bodies, and the bodies spawn at the cursor. Wait, what? I made an AABB. AABB makes vectors to show the most top left vertex and the most bottom right vertex. Before doing SAT, it can check if the AABB collide. This process is a lot faster. Rotational inertia. For circles, it's the equation here. For boxes, it's the equation here. We'll revisit this once we start doing rotational collision. Now that we're done with the lighter things, contact points. Contact points tells us exactly where 2 bodies are touching. For circles, that's pretty easy. For boxes and polygons, it uses point segment distance to find out the closest points of the contact. Rotational velocity time. For every contact point, the further the collision is from the center of mass, the more rotation it creates. After calculating the impulse, I apply it to the linear and rotational velocity. And just like that, objects can finally spin. And it just works. Never mind. Like what? Where is it going? Why is it flying? What? How far did that just go? What? Explain, please. Remember what we did for rotational velocity? Friction is surprisingly similar. Instead of applying an impulse along the collision normal, I calculate an impulse along the tangent. Static friction stops objects from starting to slide, while dynamic friction slows down an object once it's sliding. After reusing most of the same collision mass, Vyxen finally worked. Now finally we're nearly done. Polygon time, yay! This took me nearly a week to do. Yeah. The rotational inertia is this crazy equation. I don't even know how to start reading this. I also added a bunch of polygon utility functions for fixing vertex order. But most importantly, this function right here, triangulate. Triangulate. It just splits a polygon into a bunch of new polygons, which are triangles. This is important because concave polygons are hard to calculate collision for. The only way is to split the polygon into more shapes to calculate. Now a bit of work on finishing some math statements. Polygons now work. Now we have a working 2D physics engine. Circles collide, boxes collide. I'm probably going to add more things like soft bodies and just general optimization. But for now, for this devlog, it's done. If you'd like to contribute, the repo is linked down below. Bye!